In water quality problems, we're interested in tracking the concentration of a pollutant or material throughout our system. For instance, let's consider this example where we have a waste stream containing a concentration of BOD5 of 34 milligrams per liter, discharging at a rate of 0.125 cubic meters per second into a river. The river is moving at a rate of 0.15 cubic meters per second and has a background BOD5 concentration of 2.5 milligrams per liter. We're interested in determining what's the impact of this mass loading on our river system, and we want to determine at the point of discharge once that waste stream mixes with the river water. To determine what the concentration would be once this waste stream mixes with the river water, you can think of it in this dashed area right here. We're going to first need to assume that the river and the wastewater stream mix instantaneously throughout this section. And we now want to determine what's the resulting concentration. We're going to do that using a mass balance. Applying conservation of mass at the point of discharge, we know that the mass flowing in from the waste stream plus the mass flowing in from the river itself has to equal the mass once those two streams mix together. The way we can compute that is and determine what that resulting concentration is at the point of discharge. We're going to write a mass balance equation. So we would write that the product of the flow rate, QW, and the concentration of BOD5 in our waste stream, plus the flow rate of the river times the concentration of BOD5 in the river would equal the concentration of BOD, and I'll write it as at point discharge, assuming here that we're saying this is the concentration once the waste stream mixes with the river, times the total flow, which in this case would be the sum of the flow rate in the river plus that in the waste stream. If we look at this equation, we can see that we know all the quantities except the BOD at the point of discharge. So we can plug in the values that we have and determine what this concentration is. So we would have that, let's see, the point of BOD at the point of discharge is equal to 0.125 cubic meters per second times 34 milligrams per liter plus 0.15 cubic meters per second times 2.5 milligrams per liter divided by 0.125 plus 0.15 cubic meters per second. And we would get that this concentration is equal to 16.8 milligrams per liter. Because we have consistent units on our flow rates of meters cubed per second, we really don't have to worry about converting meters cubed to liters in order to be able to have consistent units here, because everything's going to cancel out and we get the appropriate concentration units of milligrams per liter.